Welcome to the Bodhi Academy. My name is Anusha Kalaso, and in today's video we will start with the chapter Electric Current and its Effect of Class 7 Chapter 10. So to begin with, in this chapter, now that we see on daily basis we have different electrical appliances that run. We have our switchboards, we have our fans, we have our tube lights. All these things, they work on a simple electric current or a circuit. So now we will see how this circuit is basically present inside any electrical appliances. Then we'll see how the connections are made, then what are the effects of this electric current and how does the electric current basically pass. So now to begin with the most simple part, we will see the symbols of electric components. So now first let us see what are the electric components for a complete circuit. So firstly we need to have the electric cell that will be the source of power. Then we will have the electric bulb. Then we'll have switch in and switch off. Then we'll have the battery and then we'll have the wires. Now these are the major components of an electric circuit. Now say you have to draw a circuit. In that case you cannot use like this whole bigger battery cells to draw and show the circuit. So in that case what we do is we use symbols that represent these particular electric components. Okay, so now first one is the electric cell and the symbol given is this two lines. One you see is the bigger line and one is smaller line. Then we have the electric bulb. In the electric bulb it is given by this kind of symbol. It is a kind of scribbling done and then it is circled over there. Then in the switch on position we show two dots that are connected by a line. When it is switch off we show the disconnect between the two dots, that is we move the line apart. Then we have the battery. Now in a battery we can't work with only one battery, right? In that case we can show two batteries that are connected. So we show one cell and another cell that are connected with a dotted line. And finally we have the wires, and wires are shown by a straight line. Okay. Now many devices such as torches, transmitters, toys, TV remotes controls uses battery. So now most of our appliances that we use, may it be our torches, may it be our TV remotes, may it even be our phones, they all consist of batteries of different sizes. However, in some of these devices, the electric cells are not always placed one after the other as shown in figure 10.2. So what we are saying is that, now see, when we look at our TV remotes, are the batteries placed like this in continuous? Are they attached to each other? No, they are placed separately, right? One is placed on one side, the other is placed on the other side, and they are not in contact with each other. So sometimes the cells are placed side by side. Then how are the terminals of the cells connected? So now here see, here they are connected to each other. So this positive and negative terminal, they are attached to each other and therefore they are connected. But if you place two cells side by side, then how are those terminals connected? Look carefully inside the battery compartment of any device. There is usually a thick wire or a metal strip connecting the positive terminal of one cell to the negative terminal of the next cell. So now what they are saying is that if you look at the side where you put the batteries, you see what? A small metal plate like or metal strip that is there, and it is connected on both the sides. So that is how both the terminals of the two cells are connected. In order to help you place the cells correctly in the battery compartment, we have the plus and the minus symbols are usually printed there so that you know which side has to be inserted where. How can we connect the cells to prepare battery for our activities? You may make a cell holder as shown in figure 10.4. So something like this. This is a similar thing is present in a TV remotes, this metallic strip is present that acts as the terminal. See here, like this kind of structure is present. So using a wooden block, 2 iron strips and a rubber bands, it is necessary that the rubber bands hold the metal strips tightly. So this is used so that these metal strips are held tightly. If these become loose over here, then these won't have any connection between them. You could also buy cell holders from the market for making batteries of 2 or more electric cells. So these are the cell holders. Place the cells in them properly such that the positive terminal of one cell is connected to the negative terminal of the next cell. Connect a piece of wire each to the 2 metal chips of the cell holder as shown in 10.5. So it is somewhat like this. See, these wires have to be connected. Your battery is ready to use. Now let's look at this activity. Make the electric circuit shown in figure 10.7. You have used a similar circuit in class 6 to make an electric bulb. Do you remember that the bulb glows on only when the switch is on the on position? The bulb glows as soon as the switch is moved to the on position. Copy this electric circuit in your notebook. Make sure a circuit diagram of the circuit using symbols of the various electric compounds. So you have to basically, here we see what that in our previous experiments what we have seen is that only when you turn the switch on, the bulb glows. When you turn the switch off, the bulb goes off. So what they are telling us is you have to make such a circuit and then use the symbols to represent that electric circuit. Okay, now let's look at this. It is much easier to draw a circuit diagram using symbols. Therefore, we generally represent an electric circuit by its circuit diagram. Figure 10.9 shows another circuit diagram. It is identical to the circuit diagram shown in 10.8. So 10.9 is. Okay, so this is a 10.9 diagram. So let's try and identify what are the things here. So this is the electric cell. This is the bulb and this is the switch. Now let's see in which position is this switch. This is in off position because these two dots are not connected by the line. So there is no flow of current that is happening. Would the bulb glow in this electric circuit? So now will the bulb glow in this electric circuit? No, because the switch is off. Recall that the bulb glows only when the switch is in the on position and the electric circuit is closed. Now this is a open electric circuit. Why? Because here there is some kind of gap that is there. This switch is in off mode. Therefore it is a open electric circuit. When this switch is closed, it is a closed electric circuit and the bulb will only glow and the current will only pass when the switch is off and it is a closed electric circuit. Now in the bulb there is a thin wire called a filament. So now in the bulb they are saying that there is a thin wire which is called a filament which glows when an electric current passes through it. So now that thin filament which is there in the bulb, it only glows when the electric current passes through it. When the bulb gets fused, its filament is broken. Now fused as in, sometimes you see that a bulb stop working. Why is that happening? Why? Because that filament which is a very thin strip over the inside, it gets broken. In that we say that the bulb has got fused. If the filament of the bulb is broken, would the circuit be complete? No. Why? Because then inside also the bulb there is some kind of open end that is created. Would the bulb still glow? No. You might have noticed that a glowing electric bulb becomes warm. Do you know why? Now when we keep any electric bulb on for a longer time or even for quite a while, then what happens? We see it gets heated, it gets warm or it gets hot. So now why is that happening? So now let's see the heating effect of electric current. Take an electric cell, a bulb, a switch and connecting wires. Make an electric circuit. This activity has to be done using only one cell. Keep the switch in off position. Now, if when the switch is off, does the bulb glow? No. Touch the bulb. So the bulb will be cool. Now move the electric switch to the on position and let the bulb glow for a minute or so. So now you turn on the switch and let it glow for about a minute. Then you again touch the bulb. This time what you will realize is that it is quite warm. After moving the switch back to off position, touch the bulb again. So then there's another one they have shown to make a circuit over here. Here what only difference what they have done is they have used nails over here. So when you turn on this switch over here, this will get warmer or hotter. Be careful not to touch them when the switch is on. After turning the switch off, you can touch it or hold it. You might have the wires get hot when an electric current passes through it. So now what they had done here was that the nails were connected with the electric wire. So now just like how the bulb get warm, the wires also heat up. So this is the heating effect of electric current. So this warmness that is created to the bulb or to the wires, it is known as the heating effect of electric current. Can you think of any electric appliance where the heating effect of the electric current is used? Make a list of such appliances. So first thing we remember are these heaters which we see. They have this coil like thing. When you turn it off, they heat up, they become red. You might have seen an electric room heater or an electric heater used for cooking. All these contain a coil of wire. This coil of wire is called an element. So now this coil, these are coils of wires. These are all wires only. They are brought together to make these coils. And this is known as an element. You may have noticed that when these appliances are switched on, after connecting to the electric supply, their element becomes red hot and gives out heat. So the amount of heat produced in a wire, it depends on its material, length and thickness. So three things we need to remember. The amount of heat produced, it depends on three things. First is the material, second is the length, and third is the thickness. Thus for different requirements, the wires of different materials and different lengths and thicknesses are used. So here what happens, see, here the wires that we used were very thick. So here the heat produced is also very high and therefore it becomes red hot. Here we used only one single wire. So therefore the heat wasn't so much as compared to the electric heater. The amount of the wires used for electric circuit do not normally become hot. On the other hand, the elements of some electric appliances become so hot that they are easily visible. Easily visible like they become red. The filament of an electric bulb gets heated to such a high temperature that it starts glowing. So now a similar thing happens with the bulb. So in that bulb, the filament that is there, it gets so hot that it starts glowing and it starts to emit light to us. So if a large current passes through a wire, the wire may become so hot that it may even melt or break. But is it possible for a wire to melt and break? Let us check it out. So now here they have given a activity. So make a circuit we used for activity 10.3 again. However, replace the cell with a battery of 4 cells. There we used only one cell. Now we are using 4 batteries. Also in place of a nichrome wire, tie a thin strand of steel wool. There we used a nichrome wire. Now we are going to use a steel wool. The steel wool is commonly used for cleaning utensils, so it is easily available at our households. So if there are only fans in the room, switch them off. Now pass the current through the circuit for some time. Observe the strand of steel wool carefully. Note what happens. Thus the strand of steel wool melt and break. Wires made from some special materials melt quickly and break when large electric currents are passed through them. So now what will happen? Here we used a very thin string. We have all seen steel wool, no? So it is such thin strands are used to make that whole scrub. So out of that whole scrub we are using just one single thin strand, so that if we heat, what will happen, it will obviously break or it will melt. So wires made from some special materials, they melt quickly and break when large electric currents are passed through them. So now they are saying that when large electric current is passed, and if the wires are made from some special material which are very thin and are not very supportive of holding so much of current, then they break or they melt. These wires are used for making electric fuses. In all buildings, fuses are inserted in all electric circuits. There is a maximum limit on the current which can successfully flow through a circuit. So now when we have seen, what happens is that sometimes our fuse goes off. So what we say, the fuse went off. What does it basically mean? That the wire inside has broken off due to extra load. Because that fuse has certain limit, we have to use it at that certain limit. The minute the load increases, that wire breaks off or it melts off. That time we say that the fuse has gone. If by accident the current exceeds the safe limit, the wires may become overheated and may cause fire. If a proper fuse is there in the circuit, it will blow off and will even break the circuit. The fuse is thus a safety device which prevents damage to electrical circuits and possible fires. Fuses of different kinds are shown for different purposes. Figure 10.14. So see, these are the fuses. These we find in our homes also, and these are used in electrical appliances. So fuses used in our houses. Fuses shown in 10.15 are used in electrical appliances. We observe the heating effect of the electric current and learned how we use it to our advantage. Okay, so this was it for today's video. So we saw about electric current, what it is, what are the different symbols used, and we also learned about the heating effect of electric current. So thank you so much for watching today's video. Please don't forget to like, share and subscribe to Bodhi Academy.